Hello there, let's have a go at this question. Okay, if you fancy pausing the video, you can do. Otherwise, let's go ahead, read the question, and let's have a go. Right, a child of mass 30 kg sliding down a slide at an angle of 40 degrees to the horizontal. Find the normal contact force between the slide and the child, and acceleration if the slide is smooth and if there's friction. Okay, so first of all, always let's draw a diagram. There's the horizontal, here's the slide, and let's put 40 degrees here. Let's treat the child as a particle. There's the weight always drops down like that, which will be 30 g. Now this is the slide, so this will be our plane, this will be a horizontal plane, and this will run perpendicular to the plane, which is the contact force. That will be contact force we call Rn, and this will then be parallel to this slide, which is running down this way, and that is running there, and that's 40 degrees there. So this is the adjacent, so we call that 30 g, which is the weight horizontal times the cos 40, so that's going down, and going down the slide in that way, it's going to be 30 g sine, which is the opposite 40. Okay, and those are the only forces at the moment acting. So first of all, we want to find the contact force. So Rn is equal to, so that's the reaction to this child, and that will be 30 g cos 40. If you just simply put that in your calculator, 3 times 9.8 times cos 40, you'll get, now I'm just going to treat it as, now on my calculator it goes 22.521 etc. So I'm just going to, just 1 second, I meant to put 30 not 3, 30 times 9.8 times cos 40, I'll get, now to freezing figures, 225 newtons. My calculator actually says 225.217 etc, but I'm just going to do it to freezing figures, that's fine. So that's my contact force. B, smooth slide. So if it's a smooth slide, I'm just going to put BI here. So if it's just a smooth slide, the only force is this downward force, which is like a gravitational pull going down the slide. So that's going to be, if we use our Newton's second law, force equals mass times acceleration, and the force here is going to be 30 g sine 40. Mass of the child is 30 times acceleration. Now just divide that through by 30 both sides, you can cancel that down, so the acceleration will be g sine 40 equals a, and therefore just put it in your calculator. A will be 9.8 times sine 40. You'll get to freezing of it, well my calculator is going 6.2993 etc, so I'm just going to say to freezing figures it's going to be 6.30 meters per second. Okay, part 2. Now part 2 is no longer smooth, it's telling you there's friction involved, and it's told you that the coefficient friction is 0.2. Now the coefficient of friction we call mu, so mu is 0.1, and you should know for friction when it's at its maximum, the formula is mu times the contact force, and then once that's activated, that's going to always oppose the motion. So in this case, the friction is going to be 0.1 times 225, which is going to be 22.5 newtons. Okay, so this Newton's second law, the resultant force is now, this is a force coming down, which is 30 g sine 40, and the only thing opposing that is this friction, which is going against it. Friction always goes against the motion, and that is going to remain the same. The child remains 30 kg. The only thing that changes is this acceleration, which is getting slowed down because of this friction. So if we now go and divide everything by 30, you'll get A equals to, just put that in your calculator. So we put 30 times 9.8 times sine 40 minus 22.5 over 30. You should get 5. Well, to three single figures, you're going to get 5. Mine calculated is 5.5493, etc. So 5.55 meters per second. So it has slowed down because of friction.